Okay, so the first half of today's section is likely review for you because it's something we cover in intermediate algebra. But again, if I'm making assumptions and I'm not adding in a detail that you need, please do not hesitate to let me know. I want to do what's best for you. I want you to be super successful in this unit. I know this is a difficult one. So what we're going to do is we're going to solve rational equations. Then we're going to go on and solve rational inequalities. Okay, like we've done we've done that with absolute value equations. Then we solved inequalities, quadratic equations. Then we solved inequalities. Later this unit, we'll talk about radical equations and solve their inequalities. So we're getting to go through this process. So in general, this is hopefully the part that you've seen before. When I go to solve an equation that has a fraction in it, my goal is I want to get rid of that fraction. I want it there no longer. And so we clear the fractions. I want to multiply by something here that is going to get rid of, it's going to get rid of my fraction. And so what would you recommend I multiply both sides of this by to get rid of my fraction? Yeah, the common denominator, the 2x plus 1. Fantastic. So I'm going to do that over here on the left, the 2x plus 1, and then I'm going to do it on the right. I only have two fractions on this, or actually two terms on this one. So this is the simplest type of problem that you can get. Okay, we solved something similar to it as part of our process of seeing if a rational graph goes through its horizontal asymptote. So we actually have already seen this a little bit. So on the left side, the good news for us is the 2x plus 1's cancel. Great, no more fraction. That's always my goal. So I have the x plus 2 left over. So far, so good. Anybody got a question or concern? Please let me know if something I do is unclear to you. On the other side, we don't have to do it this time because we're multiplying by 1, but just don't forget to distribute. In all honesty, that's the most common mistake students make when solving one of these equations on the test, is forgetting to distribute whatever number it is. So be careful. And so this is just 2x plus 1. And now I solve. You're either going to get a linear equation like this or a quadratic equation, something you know how to solve. So I'm going to put everything on the left, or my x's on the left, numbers on the right. So when I subtract 2x from both sides, I get negative x over here. When I subtract the 2 from both sides, I get negative 1 on the other side. Everybody following along? And then I'm going to divide both sides by negative 1, and I get x equals 1. Something that you have to remember to do for rational equations, we haven't had to do this for quadratic equations and linear equations, because if you remember your graphs, the domain of a quadratic, the domain of a linear equation is all real numbers, so this hasn't come up. But rational equations do have limitations on their domain, where my vertical asymptotes are. So your only other thing you need to do is just check and be sure that this does not make a denominator 0. Now, on this particular problem, the only denominator I have is 2x plus 1. When I plug 1 in, when I plug this solution in for x here, does it make my denominator 0? No. Okay. In fact, you can check the whole thing and make sure that you got the right answer. But I'm going to be satisfied, and my solution is the number 1. If you have a question, ask it. If not, the problem just to the right, exercise 1, is super similar. Please go ahead and do that. So for this particular problem, what'd you multiply both sides by? Fantastic. I appreciate that. X plus 2. So I'm going to do that on the left side. I'm going to do that on the right side. So on the left, the good news, and this is why we do this, the x plus 2's cancel. And what am I left with on the left? What remains? Yes, that is true, x minus 6. And on the right, just don't forget to distribute that -1, and you have negative x minus 2. Anybody get something different that we have to talk about? Okay, I'm going to put my x's on the same side, so I'm going to add x and get 2x on the left. I'm going to add the 6 and get 4 on the right. Divide both sides by 2, and I get the x value 2. When I put that into my denominator, 2 plus 2 is 4, so that works out great. There is my solution. Solution set is the set with 2 in it. All right, well, the other problems, the other 4 problems we have before us that are equations are slightly more challenging. And if you have any question, let me know. So the same principle applies. For example, 2, I want to have something that has no fractions to it. So I'm going to multiply by the common denominator. But before I do that, I'm going to factor all of my denominators just so I know what my factors are. So x minus 2, that's great. That's all set. X plus 2, great, all set. This one right here, x squared minus 4, that's a difference of squares. So that's x plus 2 and x minus 2. I try to keep the factoring fairly reasonable for you. I'm not trying to torture you. I'm just trying to help you learn a little math here. What is the common denominator that I am going to multiply every one of these fractions by? Yeah, the way you find the common denominator, if you've forgotten, is you just take one of every factor. And if there's a power, you take the highest power. That's it. One of every factor. There's a power, the highest power. So I've got an x plus 2 times an x minus 2. So I'm going to put one right here, x plus 2, x minus 2. I should have left myself a little more room, but I'm going to squeeze one in right here, x plus 2, x minus 2. And then for the last fraction, x plus 2, x minus 2. Okay, so I like to write down what I'm multiplying by times every single term. That way I can cross things out. That just makes me happy. And it is all about me. All right, so here we go. The first fraction, I'm going to cross out the x minus 2's. And when I distribute, what do I have as a result? Perfect. X squared plus 2x. Somebody started to say it, then lost confidence. X squared plus 2x, fantastic. Don't forget to distribute. Okay, that's the key here. From the middle fraction, I'm going to cancel out those x plus 2's, and then I have 1 times x minus 2, so that's just an x minus 2 right there. And then all the fun happens on the right side because the x plus 2 and the x minus 2 cancels, and I'm just left with 8. So you're either going to end up with, in every problem, you're going to end up with a linear equation like we did the first 2, or a quadratic equation like we have on this one. Okay, so again, you hopefully know how to solve a quadratic. You have 2 choices. If it factors, you're going to factor, or you can always use the quadratic formula. It works no matter what, every time, every single day. So I'm going to move everything to the right. So I've got x squared. 2x plus x is 3x. I'm going to subtract the 8 from both sides, and I get -10, and that equals 0. Everybody tracking with me how I ended up with x squared plus 3x minus 10 equals 0 there? I don't want to lose anybody on the introductory algebra. I know sometimes things can seem harder when you're learning it as part of a new thing. This will factor, so I am going to choose to factor. If you did not see that it would factor, you could use the quadratic formula with an a of 1, a b of 3, and a c of -10. Okay, we will end up in the same place guaranteed. But as I'm writing down my parentheses, what are the 2 factors of -10 that are going to add up to +3? I'm going to go +5 and -2 because they have to add up to a +3. Okay, so some said +5, some said -5. I'm just letting you know why I picked what I picked. And so then the principle of 0 products, I'm just going to move this over to the side a little bit, says that then each of these can be 0. And so the first one, your first solution is -5. and then the second solution is 2, and there's my potential solution set. But remember, check, make sure your answers are in your domain. Some problems they will be, some problems they won't be. You got to check. So when I put -5 in my denominators, does -5 make any of my denominators 0? No, it does not. That's a good answer. I'm going to put a check mark under it. Does 2 make any of my denominators 0? Yeah, it makes the first one, and it also makes the last one, but the first one, 2 minus 2 is 0. We can't have 0 in the denominator of a fraction. It's not in the domain. If we graphed this, there'd be a vertical asymptote there, so I am going to cross that one out. So my solution set just has one element in it, and it's -5. We good with that? Everybody see, do you understand why I got rid of that one solution? All right, well then try exercise 2 right next door, please. If you have a question, wave your hand in the air, I'll come to you. Happy to help. Okay, so on this particular problem, just like the previous one, I've given you a difference of squares. Again, I'm interested in the process, not in torturing you with crazy factoring or anything here. So the 4x squared minus 1 factors to 2x plus 1, 2x minus 1. So that means my common denominator is just going to be the 2x plus 1, 2x minus 1. Anybody get a different common denominator that we need to see why? All right, well, then I'm going to go through here. I'm going to multiply each of my fractions by 2x plus 1 and 2x minus 1. So bear with me for just a second. 2x plus 1, 2x minus 1, and then 2x plus 1, 2x minus 1. So I've multiplied by each of them. So when I cancel on the first one, whoo, that's fun. What's left on the first fraction? What do I have? Okay, sounds great. I appreciate all the voices. And then when I cancel the 2x plus 1 on the second fraction, what do I have left? All right, wonderful. And then plus, and then the 2x minus 1s, and what do I have there? Okay, fantastic. Okay, so we didn't end up with a quadratic equation this time. We've got a nice, cute linear equation, which we're always thankful for. So on the right side, I'm going to do a little simplifying. 6x and 6x is 12x. -3 plus 3 is 0, so there's nothing there. So I'm just going to put all of my x's on the left like I like to do. So when I subtract the 12x from both sides, I have -4x over here, and I'm left with 0 over there. That's not a contradiction. we still have an x in the game here, so you're not done with the problem. 0 is a number. When I divide by -4, what's 0 divided by -4 going to give you? 0. 0 divided by anything except 0. There's a debate in the math community about that. That's a fun debate. But 0 divided by -4 is going to be 0. Does that make any of my denominators 0? No, it makes this one -1. It makes that one +1. It makes this one -1. So that is a perfectly acceptable solution. So I'm going to throw it into a set. Is anyone confounded? Are we doing okay? Yes. No, it's a big debate because in math, so it's a big debate in math because 0 over 0, you can kind of quote unquote prove or demonstrate that it could equal 0, it could equal 1, it could equal infinity. So there's different ways to approach the problem, so that if you want to get in a fight with a mathematician, I mean, who wouldn't, then go ahead and tell them that 0 over 0 is whatever you definitively think it is, and then come to blows with them. So yeah, so math is a very, very violent and unpredictable area. So if you ever can take a history of math class when you go to university or history of science, the good times roll. There's Isaac Newton and there was a competitor mathematician. They both claimed to invent calculus at the same time, and so they dueled about it. There's a fun guy. So I took a history of science class. There's a guy named Tycho Brahe, and he was an astronomer. And he proved something, and he got in a duel, and his nose was cut off. So he walked around with a gold nose. I mean, who wouldn't? I would love a gold nose. So he had a gold nose. So any painting you see of him has. Anyway, all sorts of fun math and science stories. Sorry, I know that we've got to do this, but there's lots of interesting things. All right, do the next problem, exercise 3. Yes, what's your question? So how did I get the -4x? Let me just come right over here. I'm going to draw a little arrow. So I've got the 8x is equal to 12x. So I want to get all my x's on the left. So I subtracted the 12x from both sides. So 8x minus 12x is -4x. And then 12x minus 12x is 0. Better? Awesome. Great question. I appreciate you asking it. Always make sure you're clear on these things. Go ahead and work exercise 3. Share. until I think of another one. All right, so t squared minus 49, that's a difference of squares. So I factored that. So then the common denominator, again, I'm trying to make these nice and straightforward problems just to review this process. So it's t plus 7 times t minus 7 is my common denominator. Does anyone not understand why I'm coming to that conclusion of the common denominator, t plus 7, t minus 7? Are we okay with that? All right, so the first fraction, the t minus 7s cancel. So what do I have left? What's my first bit here? Perfect, I appreciate that. Thanks for helping me out. Then the next one, the t plus 7s cancel. So what is next? Okay, 2t minus 14. And then on the other side, everything cancels. It's a canceling party, and I'm left with 14. Again, another linear equation, so that's great news for me. So I'll simplify the left. T plus 2t is 3t. 7 minus 14 is negative 7. I'm going to add the 7 to both sides, so I get 3t is equal to 21. And then divide by the 3, and I get t is equal to 7. That's great. You've done great work if you got to t equals 7. What's the problem with t equals 7? It makes one of my denominators 0. It makes my first one and my last one, both of them 0, and would be great. So since t equals 7, up here 7 minus 7 is 0. I unfortunately have to throw that one back. And so my solution, there's no other solutions like the exercise 2, or example 2, we had 2 solutions to choose from. And since one didn't work, we still had the other one left over. That's not this situation. So my solution here is the empty set. Not the set with 0 in it, okay, the empty set. I've got one more of these. So again, if you have any questions at all, please be asking them. Exercise 4, please solve that, that rational equation. Just going to give a little nudge in the right direction because these denominators are a little different. What's the common denominator you've multiplied everything by here, hopefully? Yeah, the only factor I have is an x, right? So the way you find your common denominator is it's one of every factor and then the highest power. The only factor I have is x. The highest power of it is x squared. So you should be multiplying everything by x squared. All right, so I'm going to do what you just told me to do. I'm going to multiply everything by x squared here. So my first one, x squared times 4 is 4x squared. And then here, 7 over x times x squared. This x cancels with one of these, and I'm left with 7x. And then on the other side, the x squareds cancel, and I'm left with -1. So it's a quadratic. I'm going to put that -1 over on the other side. So I'm going to have 4x squared plus 7x plus 1 equals 0. At this point, you've got to solve the quadratic equation. So if you use the quadratic formula, your value of A is 4, your value of B is 7, your value of C is 1, and you can go forward. I'm going to factor. So I know everybody here is at a different level of factoring, maybe even have different processes. I'm just going to stay consistent with how I've showed you in the past and how I teach intermediate algebra. So I'm just going to use the AC method or the box method or the California method, whatever you want to call it. It's all the same method. So I'm going to multiply the 4 times the 1 and get 4. Oh, this is not going to factor. I was so confident that it was going to factor too. Look at me. Great. So we do have to use the quadratic formula. Yeah, I know. I was confused too for a second. Okay, so I'm going to use A is 4, B is 7, C is 1. So let's go for that. So my quadratic formula, well, remind me, it's been a while, clearly, because I thought I was going to factor. What do I do with my quadratic formula? Negative B, sure. So B is 7, negative B plus or minus. What's next? Okay, square root of B squared minus 4AC, the discriminant. So B squared, 7 squared is 49. Minus 4 times A, which is 4, and C, which is 1. And then what's in the denominator of my quadratic formula? Beautiful, 2A. So 2 times 4 is going to be 8. I'm going to move up to the top over here of my white space so that I have room to work. So the way I like to do this, I'm sure your preference is probably different. I like to start with this product in the discriminant as I'm working. So I've got -7 plus or minus the square root of 49. And then 1 times 4 is 4. 4 times -4 is -16. Underneath the radical, 49 minus 16 is 33. 33 has no factors that are perfect square. It's just 11 times 3. That's not super interesting. So I can't simplify that radical. You're welcome to give a decimal approximation, but that's not what I want. I want the exact answer. There they are. Okay, they're not going to make the denominator 0. The only thing that would make the denominator here 0 is 0. So I'm just going to be lazy and put some squigglies around that. There's my 2 solutions to this rational equation. All right, so that's kind of our review of solving rational equations and doing that. Does anyone have any questions before I move on to inequalities? Okay, I'm going to trust that you're telling me the truth because I don't know why you wouldn't. So example 3, this is my next example. It's an inequality. So I want to know, when is this fraction less than or equal to 1? Okay, so you're going to hopefully help me. We'll see if you remember, because we've done this twice before. This is our 3rd time doing inequalities. Can anyone remind me what is the first step to solving an inequality, whether it's an absolute value inequality, a quadratic inequality, and now a rational inequality? What was that? Solve the equation. Yes, step 1. Solve the equation. What that means is, instead of an inequality sign, just put an equal sign and solve it. Now, the good news is we've already done that. Okay, we did that up in example 1. So I just saved ourselves a little work and a little time. The solution to the equation that we already saw at the very beginning is 1. Okay, so that's the point where these 2 things are equal. So I'm just going to put my solution set right here to remind me of that. Okay, awesome. That's the first step. There's 3 steps. That's step 1. Step 2. Yes, the number line. And remember, the number line, the reason we do the number line is it represents the domain. And now here's where it gets a little more interesting than it has in the past. Because when we solved absolute value inequalities, the domain of an absolute value function is negative infinity to infinity. When we solved quadratic inequalities, the domain of the quadratic is negative infinity to infinity. So rational, we have a little bit more to think about here. So let me draw my number line. So number line, negative infinity to infinity. But with my rational, what do I have to leave out? Where's my vertical asymptote going to be on this particular problem? I'm sorry? No, not quite. When do we have a problem with our domain of a rational function? Where do I have a vertical asymptote? How do I find it? You're not engendering me with a lot of confidence here. Woo, I'm scared. Yes. Denominator what? Yes. So what we have to do is the denominator, 2x plus 1, remember it can't be 0. We can't divide by 0. This is how I find my vertical asymptotes. That's the first step to graphing a rational equation. Okay, that's going to be on the test, by the way. Woohoo! So I'm going to subtract the 1 from both sides. So 2x can't be negative 1. I'm going to divide both sides by 2. And so I have a vertical asymptote at negative 1/2. That's a limitation to the domain. So I'm gonna put a little line at here, put negative 1/2. Now, I am totally a forgetful person. Okay, if you knew me outside of class, you would know that. So I do not want to make a mistake and think that that's a point of equality. Okay. So what I'm going to do, and this is what I recommend you do, I am going to make sure I note that that's an asymptote. So I'm going to draw an asymptote right through negative 1/2. That reminds me that that's not a point of equality. I am never going to use a bracket at negative 1/2 because I can't use that value. There are no other asymptotes in this problem. Great. My point of equality is 1. So I have now broken up my number line into 3 intervals that I have to check. I have negative infinity to negative 1/2. I have negative 1/2 to 1. And then I have 1 to infinity. And I know in the past we've gotten a little lazy with the absolute value and the quadratic because they'll alternate. But rational functions don't have to alternate. Okay, so you have to check all 3 intervals to be sure. Now this one probably will now that I've said something, but you get my drift. All right, so here we go. I'm going to put in negative 1 out of this first interval. I'm going to put that into my fraction. And I'm going to determine, is it less than 1 or is it bigger than 1? So when I put negative 1 in the top, I have negative 1 plus 2. In the bottom, I have 2 times negative 1 or negative 2 plus 1. Well, that is 1 in the top. That's negative 1 in the bottom. So when I put in negative 1, I get out negative 1. Is negative 1 less than 1 or is negative 1 bigger than 1? It's less than. So that means in this part of the interval, we're going to get values less than 1. Everybody with me on how I came to that conclusion? And by the way, I just strolled into without writing down. The third thing is we got to check the intervals. That's on a note sheet of yours somewhere in the past, but I'm writing it down again just so it stays fresh. All right, I'm going to pick 0 in the middle interval because I always like to plug in 0 when I'm able to. So in the top, that's 0 plus 2. In the bottom, that's 0 plus 1. So that's 2 over 1. Is 2 over 1, is that bigger than 1 or is that less than 1? Okay, it's bigger than 1, so I'm going to put a greater than sign there. And then in the final interval, I'm going to put in, let's go ahead and put 3 or 2 or 92. It doesn't really matter. I'm going to put 3 in. So in the top, I have 3 plus 2. In the bottom, I have 6 plus 1. That's 5 over 7. Is 5 over 7, is that a number bigger than 1 or is that less than 1? Okay, less than. And so which interval or intervals solves my inequality? When is my fraction less than or equal to 1. I'm sorry, what'd you say? Okay, negative infinity to negative a half. These numbers here, the -1, the 0, and the 3, those are just my test numbers. Those are numbers in the intervals. They do not come up again. You don't need to worry about them. The intervals here on mine are pink. Okay, so the first one is negative infinity to -1/2. We saw that in that interval, it's less than 1. So I'm going to write that interval down. Negative infinity to -1/2. Question. Let's see if you're still awake. I know it's tough sometimes to stay awake in this class. Am I going to put a bracket or am I going to put a parenthesis at the -1/2? I know I got an equality, but it's not a point of equality. At -1/2, we have an asymptote. So it's always going to be a parenthesis at an asymptote, no matter what. There's another interval that's less than. Where does that interval start? And it goes to, and now this one, am I going to put a bracket or a parenthesis at 1? I'm going to put a bracket because I do care about the equals. I have an equal sign here, and 1 is the point of equality. That's the solution to the equation. So I put a bracket there. All right. Your problem is going to look super similar. We already solved the equation up at the top in exercise 1. So go ahead and give that problem a try. See how you do. Bless you. All right, just for time's sake, to keep us moving, because I want to make sure we get to that last problem and review the graphing. So solve the equation. We already did that. That was exercise 1. The point of equality for this problem is the value 2. Okay, so we solved the equation already. It is the value 2. So I'm just going to write that right there. Now I'm going to make my number line that represents my domain. So here it is, my number line from -infinity to +infinity. But again, it's a rational function. So what number, what x value do I have to leave out of the domain? -2, because my x plus 2 cannot equal 0. So x cannot be -2. So I'm going to have an asymptote there. So I'm going to draw a nice dotted line because I will forget. My point of equality is 2. So there's my number line. I've divided my number line up to into three intervals. -infinity to the asymptote at -2. From that asymptote at -2 to the point of equality 2. And then from 2 to infinity. And I need to now check each of those intervals and see in each interval, are we less than -1 or are we bigger than -1? Okay, so these are the endpoints of the interval. That will not change. The values I pick now are test values. Okay, they are not endpoints of the interval. So for instance, if I pick -3 right here, when I plug -3 in, I have -3 minus 6 over -3 plus 2. And -3 minus 6 is -9. -3 plus 2 is -1. So that equals 9. Is 9 bigger than -1 or is 9 less than -1? Okay, bigger than -1. So we're going to put a greater than there. In between the two, I have 0. So 0 minus 6 in the top, 0 plus 2 in the bottom. That becomes -6 over 2, which is -3. Is -3 bigger than -1 or is -3 less than -1? It's less than, smaller, great. And then finally, I'm going to pick 3 from this interval. Doesn't matter, pick whatever you want. If you picked different values than I did, you should be coming to the same conclusion that I do. That should not change. So 3 minus 6 in the top, 3 plus 2 in the bottom. 3 minus 6 is -3. 3 plus 2 is 5, so -3/5 or -0.6. Now be careful on this one. Is -3/5, is that less than -1 or is it bigger than -1? It's closer to 0. So it's going to be bigger. I know it's tough when they're both negative to compare. But if you draw the number line, -3/5 is moving towards 0. So it's bigger than -1. So the solution to this inequality that I asked you to do right here, when is x minus 6 over x plus 2 less than -1? Well, that happens in this middle interval. So I'm just going to write it right above. That happens from -2 to 2. Parentheses on both ends. Parentheses on the left because of the asymptote. Parentheses on the right because I'm not interested in the equality. Now, I know that this got kind of cramped here. Sorry about that. I was trying to make sure I only used 2 pieces of paper instead of 3. So I said, okay, now that you've done all the work, you can really easily solve the fraction greater than or equal to -1. That's going to be the other 2 intervals. So that's going to be from -infinity to -2, parentheses, because of the asymptote, union 2 to infinity. Oops, I got to put a bracket around that because I am interested in the equality this time. Stick to those 3 steps. So combining the 2 things that we've done so far, solving equations, that's the review, but probably the harder part to the process. And then you do your number line. Okay, we've got 4 problems left. And then it's the weekend. So I know we're all happy and excited about that. Let me back up just a little bit so that we can. All right, so example 4, we're going to do what we've done every time we've encountered equations. Now we're going to look at graphs and we're going to solve the equations from the graph. Again, let me just make a little caveat. The graphing site that I use does not actually print out the asymptotes. So they're always obvious. The vertical asymptote on this problem right here is x equals 0. I will never do a decimal or a fraction on you on something like this because I know I don't want you to feel like you're guessing. It'll always be an integer. Okay, your vertical asymptotes on these graphs. Okay, I'm not trying to trick you. I'm just trying to see if you're learning. So let's go ahead and do this. We're going to do the things that we've done all along. I want to know, when is this function equal to 0? When is this function less than 0? And when is this function, I don't know what's going on with my fingers, I typo right there. When is this function bigger than 0? And then, of course, I copy and pasted so you can see that I've made the same typo in every problem. Good job, Prickster. Okay. So help me out. We've done this before. This is not anything new. We're just doing this in our new situation here. Where is this graph? At what x value is the function value 0? Not at 0. 0 is an asymptote. At 1. Yeah, right here. I'm going to make a dot. Nice blue dot right there. At that value, where that blue dot is, that's when the function value, the y value, is 0. Goes through the x-axis. So that happens. The solution set there is 1. It doesn't happen anywhere else on this particular problem. Okay. The B problem. The B problem says, where is this function less than 0? So where is it below the x-axis? So do this for me. That is in one part to the graph. So what what we're doing here with the graph is what we just did on the number line. We've just identified the point of equality. We can see the asymptote here. So we have 3 intervals on this graph now. We have the interval from negative infinity up to the asymptote at 0. We have the interval from 0 to 1. And then we have the interval from 1 on forever and ever and ever. So what I want you to do is I want you to put your pencil or pen or whatever you're using on the part of the graph that you think is less than 0. Okay, there's only one part of this graph. There's only one interval of those 3 that I just identified that's less than 0. Okay, so here's where it is. This part right here where my pen is, that's the part that's less than 0. It's below the axis. Everybody tracking with me? So now I want to give the x values that produce these y values that my pen is on. So where do those values start? What's the lower limit? 0. Not negative infinity, because negative infinity, we're back up here. We're above the x-axis. So it starts at 0. And then where does it stop? At 1. That's that interval from 0 to 1. In this little gap right here from 0 to 1, all the y values are below the x-axis. I'm not interested in equality. I got to avoid that asymptote. So the asymptote gets a parenthesis. The point of equality gets a parenthesis. The last one, C. Where is this bigger than 0? Well, bigger than 0 means above the x-axis. So again, where is this above the x-axis? Well, can we all agree that this part of the graph, this left part, can we all agree that that's above the x-axis, that that's bigger than 0? Are you spotting that? Okay. I hope so. And if you're not, you ask me a question, because I'm going to put a problem or 2 just like this on the test, like I have on other tests. Just, can you read a graph? So that happens. The first interval this happens is from negative infinity all the way up to the asymptote, which is 0. And then I haven't left myself a good amount of room, so I'm going to put a union symbol right here below it. And this also happens on another interval. What's the other interval that this is bigger than 0? Where does it start? At 1. You can see it pops up above the x-axis here. It starts at 1 and it goes to infinity. I didn't ask you for equals, so all of the things are parentheses. All right, your time to shine. Exercise 6, exact same question. I copied and pasted, that's why the typo's there. So go ahead and determine the answers to the 3 questions. All right, so this one equals 0 right here. So what is the answer to the A part? Where is that equal to 0? Great. Anybody get something different that we have to talk about? So now, along with the asymptote, we have 3 intervals. We have from -infinity up to -4 on the x-axis. We have from -4 to this asymptote at 0. And then we have from 0 to infinity. There's 3 intervals. Okay, so this is just the graphical representation of what we did analytically at the bottom of the previous page. Okay, so now when is this less than 0? Well, there's only one interval that this is less than 0, meaning below sea level, below the x-axis. And what interval is that? Yep, -4. It starts right here. I'm just going to trace in purple. These are the x values that produce those y values that are below the x-axis. So -4 to 0. I am not interested in the point of equality, so I'll put a parenthesis here. And I'm never going to put a bracket at the asymptote, so I'll put a parenthesis there. Then the C problem. I'm going to write C over here so that I can have a little bit more room. The C problem, when is it bigger than 0? Well, what's the first interval it's bigger than 0? -infinity to -4, well said. I'm not interested in the equality, so I'll put a parenthesis. Union. What's the next interval that it is bigger than 0? 0 to +infinity. Perfection. All right, one more of these that you're going to identify in the graph. This graph's a little bit more complicated, but it's the same premise. So give exercise 7 your best shot. So the A part's the problem. This graph goes through the x-axis one time. What is that value that it goes through the axis? Okay, 0. Don't be fooled. Again, I use a website that this is a horizontal asymptote. It's not going to go through. I'm not going to play any games with you. Okay, if my graph's going to go through the x-axis, it'll be like the other ones. It'll be very definitive. Okay, so don't second guess yourself. So this only happens one time right here at 0. So then the B part to the problem. Well, I've now divided this up into 4 things because notice this problem here has 2 vertical asymptotes. It has a vertical asymptote here at -2, has a vertical asymptote here at +2. Okay, so this one has 2 asymptotes. Okay, so when is this less than 0? Well, this happens a couple times. 2 intervals of the 4 are less than 0. Give me one of them. -infinity to -2. If you're not seeing that, please let me know. But what we just did is describe the x values that produce this part, this left part of the curve right here. Union, What's the second interval that is below the x-axis? It's right here. I'm going to trace it in green because it makes a nice pretty color. So right here, right below the axis. So that again, yes, is 0 to 2. The C part to the problem, when is it above 0? Well, that again happens in 2. So give me one of the two intervals that it's above the x-axis. Okay, -2 to 0. And then the other one is the right part of the graph right here that is fully above. So that is 2 to infinity. Please make sure that you can read the graphs. It breaks my heart when I'm grading the test and I mark things wrong because the answers are all right there. It's just a matter of getting the information off the graph. So last thing, this is a review problem, okay? Because I know that last section was a difficult section. We're going to do this together. So here's what I want you to do. We're going to go through the 6 steps. Step number 1, I'm going to give you 60 seconds. I want you to identify any vertical asymptotes and then put the vertical asymptote on the graph. All right, what did you get as the vertical asymptote? Okay, so remember, you always take your denominator. So here's my denominator, x plus 2. And you say, okay, where is that equal to 0? Because the denominator of my rational function cannot take on that value. And so when I subtract 2 from both sides, that is -2. It's not a solution set. That is a line. You've just given me the equation of the vertical line. That is the asymptote. So I'm going to just, right over here in lovely red, I am making a dotted line. So far, are we so good? Okay. 2, 60 seconds. What's the horizontal asymptote? And then put it on the graph. Right, so what's the horizontal asymptote of this? Y equals what? Okay, 1. So remember, there's 2 situations. The first situation is the degree of the denominator is bigger, which is not this one. What's the what's the horizontal asymptote when the degree of the denominator is bigger than the numerator? 0. Yeah, it's the x-axis. When the degrees are the same, you take the ratio of those coefficients. So 1 from the top, 1 from the bottom. And that's where that comes from, in case you were curious. Okay, so I'm going to make my dotted line. I'm going to do the best I can. I'm excited that it's the weekend, so I might be a little jittery here. Boom, there we go. All right, step 3. I want you to find the I want you to find the Y-intercept by plugging in 0 into the function. I'm going to give you 30 seconds to do that and mark that point on the graph. Okay, when I put 0 into the function, the numerator becomes 0 minus 6. The denominator becomes 0 plus 2. And so that is -6 in the top, 2 in the bottom. So the function value at the x value 0 is -3. So I'm going to make a dot right here at -3. Great. Next thing I want you to do is I want you to find the x-intercept. I want you to set the rational function equal to 0. All right, so I'm going to set this function equal to 0. But then I gave you a little hint when we talked about this, that a fraction can only be 0 when the top is 0. 0 divided by a number. So I don't have to worry about this except to say x minus 6 equals 0. So that happens at the x value 6. So at the x value 6, which is way out here, I have the value 0. All right, we've got one more question to answer, and then we already know what the right half of the graph looks like. So question 5, does it go through the horizontal asymptote? So figure that out. Just reminds me, in order to figure out if it goes through the horizontal asymptote, I take my fraction, and what do I set it equal to? In this case, 1. Whatever the value of the horizontal asymptote you found out in step 2, that's what you set it equal to. What we want to know is, does the graph take on this y value that we put the dotted line? Okay, and if so, where? So I can mark that point and know that. So this is what we started off today talking about. In fact, we set this equal to -1 earlier. So I'm just going to multiply both sides by x plus 2. Pretty quick thing to go ahead and solve. And so I have x minus 6 is equal to x plus 2. And when I subtract x from both sides, you notice that I end up with a contradiction. When I end up with a contradiction, that means it does not go through the horizontal asymptote. So the answer to this question is no. We'll use an exclamation point. We'll be excited about it. No, it does not go through the horizontal asymptote. All right, given that information, here's what I want you to finish up. I'm going to give you 90 seconds. I want you to choose any points you need to finish the sketch. Okay, so choose points to finish the sketch. Okay, it doesn't really matter what x values you picked. We're just drawing a sketch. Okay, the only thing that I'm going to mark you wrong on is if you draw some sort of picture that like adheres to the asymptote. Sometimes students want to draw something and just draw something that mimics the asymptotes. That's not at all what this looks like. That's why we're getting a couple points, is just to get the scale of this. So on the right side of this, we've got the scale of it. We've got 2 points. If you want to get more points over here on the right, pick anything you want, but I'm pretty content. So I'm just going to go ahead and connect these dots with a nice curve that gets closer and closer to my asymptotes, because asymptotes define the behavior of a rational function. And then what I did is I picked the x value -4, and I picked the x value -6. I have no real secret reason. The only reason I picked even numbers was so that it would divide out and I wouldn't get a decimal. That's the only thing going on in my brain, but it wouldn't have been bad if you got a decimal, okay? So it's not a big deal either way. So when I put in -4, the top is -4 minus 6 or -10. The bottom is -4 plus 2 or -2. So at -4, I go up 5. So here's my first dot. And then when I put in -6 in the top, -6 minus 6 is -12. -6 plus 2 is -4. And -12 divided by -4 is +3. So at -6, I'm at +3. So my graph is going to look something like, it's just going to roll down something like that. I put the -4 at -3. Yes, I sure did. Good job, Perkster. We're finishing with a flourish this week. Sorry about that.